So here's day 7 in your notes, and basically it's the second last day of trig in the sense that tomorrow is Wednesday, last day of the week for you guys because Thursday, Friday, teacher convention. And then when we get back to school on Monday, you'll do trigonometry practice exam. The very next day, trig exam. Then we move on. Okay? So the one nice thing I tried my hardest to not make you guys have tests on Monday. Unfortunately, there is one test on a Monday. Okay, so this is review of what we already know. SOHCAHTOA. Does everybody see that? It's a mnemonic. Okay, SOHCAHTOA, SOHCAHTOA. And then the thing underneath is what's on your formula sheet. So this is what you get on your formula sheet, okay? What do you do when you're solving for sides? What do I put on the left side? You put those little ones there if you're solving for sides. Okay, and then at the bottom of your page, I think it says something about if you're given a ratio, what do? Use the inverse. Is that at the bottom of this page? Yes, right here. If you're given a ratio, use the inverse. So the ones with the -1, that's for solving for angles. So you only have 2 jobs in this unit. Solving for sides, solving for angles. The secondary functions are for angles. The primary functions are for sides. Okay, and we put a little 1 there to help us with our cross multiplication. All right. And my screen is a bit glitchy here, so I'll just grab this. Okay, so see where it says sine A, cos A, tan A? You need to put the ratios, okay? So according to A, and if you had different color pens, this is good. If you have one color pen, you got to be creative. For the labels, according to A, 4 is op, 3 is adj, 5 is hype. Do you agree? Okay, so let's get these ratios. Sine A, sine A, what's my ratio? 4/5. What's cos A? Has to be over 5, because, good, this time it's 3/5. Remember that pattern. Sine and cos always do the hypotenuse. And then tangent is on its own without the hypotenuse. Op over adj, 4/3. Now switch color pens if you got it. Now we're working on C. According to angle C, 3 is op and 4 is adj. According to angle C, hype stays the same. So sine C would be the same as cos A, 3/5. And cos C would be the same as sine A, 4/5. Because the op and the adjacent switch. It's like a label switch. And the tangent of C is just going to be the opposite of the tangent of A because opposite and adjacent switch. And then you can use any one of these formulas, there's 6 of them there, to find the angle A. So use any one. And everybody just pick a different one and see if we get the same answer for A. Or pardon me, you can only use the first 3 for A. So pick any one of those, go second function, I'll use cos. So I'll go second function cos, I put a bracket, 3 divided by 5, and I'm getting 53. Okay? Now for C, pick any one of these. I'll use tangent just for fun. Yeah, you could subtract from 90, right? Yes, you could. So I'll just use tangent inverse tangent, bracket, 3 divides 4, close bracket. I got, after rounding, 37. And what do you know these two add up to? They add to 90. Okay, good. Because those two acute angles plus this angle down in the corner have to add up to 180. And this guy's going to be 90 every time. So these two have to add up to 90 as well, like it shows there in the bottom. Good. So that is a review. On your page, do you have this thing called steps? Do I have that on mine? Yes, I do. Okay, steps. Draw triangles to represent the situation. That's often the hardest part. So I'll show you some examples where it's a little bit difficult. Then, of course, you label, like I've always told you. And then you figure out which equation. And it looks like you can fill in the blanks on the op, adj, and hype. Determine which equation. 3 and 4 are basically the same step. And then the last step is execute. What are the ways of executing? Cross multiply or inverse trig. Those are the only two options for the execution step. You're either solving for a side, which you cross multiply, or you're solving for an angle, which you do inverse. So there's only two options for solve. Set up, there's 3 options, sine, cos, or tan. You got to pick which one. And if you got the labels and the proper sketch, you're going to have no problem. All right. The next thing says, and I'm going to have to highlight this for you, solve the triangle. So if you ever see that, you have to sort of translate this into English. Solving a triangle means you need all angles, all sides. Okay, solve the triangle. You got to figure out every little detail about the triangle. Given that angle B is 90, so there's your right angle right there. Draw the little box. AB is 9, so length AB is 9 centimeter. And BC is 17 centimeter. All right. So how do I solve for AC? There's a couple options here. Pythagorean theorem, I heard. Why do you want to use Pythagorean theorem? Because you don't know any angles. You could probably find an angle, right? Could you find these angles? Yeah, you could. But we could use Pythagoras. I just wanted to remind you that you could do that. Are we solving for a long side or a short side? Long side. So do we add or subtract? Add. And then we just got to put the squares in. 17 square and 9 square. So it'll be some number bigger than 17. What is it? 19? 17 square plus 9 square. Ooh, 19.2. Does it say anything about nearest whatever? No. So you guys want to use 19? Okay. It's 19.235, but we'll use 19 on our diagram. Okay. Now we need to find out the angles. Let's figure out angle C. Angle C. Which function will give us C? And I don't want you to use 19. Just use the ones that they gave us. Don't use 19. Because if you don't take all your decimals, you're going to have some degree of error. The accuracy won't be there. So just use the ones they gave you. 9 is which label? Op. 17 is which label? Adj. So to solve for angle C, do you use tangent or second function tangent? Second function tangent. And what goes in the bracket? The ratio of sides. 9 over 17. So second tan, 9 over 17. Looks like 28 after rounding. If you have one of the acute angles, how do you get the other acute angle for free? Good. 90 minus 28. I love it. Miss Teague said 180 minus 90 minus 28, but we're smarter than that. We shortcut it. Pardon me? Just my fingernails. I don't. I have a stapler. All right. Are we okay on this? Did I skip any steps? I skipped a lot of steps. I skipped steps here. Right? Oh, breaking down. Hello. Did I skip steps here? Yeah, this is a shortcut. But I do Pythagoras so much in my life, why do I need to show all the steps? Did I skip a step on this one? Yeah, I skipped the first step, which is build the equation. I know to solve for angles, I just need to use inverse. So whether it's sine, cos, or tan, whatever ratio it is, it goes with it. So I skip steps here, I skip steps here. I also skip steps here because I know that these two add up to 90. So just 90 take away the other will give the other. All right, so you guys know what I mean when I say solve a triangle? What do you got to do? All angles, all sides. Good. Now what do we got? A word problem with no picture. This is what's going to be difficult for you guys. The word problem without the picture. Because I can't read it for you. If it's a test and you're like, Mr. Lineweber, I can't read this, you put your hand up and I come and see you. All right? Now, if it's every single question, then that's a problem. But if it's like one question, you're like, I just don't get what it's saying, I can give you some advice. I can give you a little push, and then you'll have some success. Okay? So first of all, in the back of your mind, what are you trying to draw? A right triangle. So this is all basically you're looking for. Now let's try to make that happen with this word problem. And this is in the back of your mind. I got to make it look kind of like that. Okay? So a 20-meter tower. I think this one was on the quiz. 20-meter tower. 40-meter wire attached to the top of the tower. Must make an angle with the ground. I think this was Evel Knievel question. Do you guys remember that? Quiz 4. Find the angle of inclination. What's an angle of inclination? On the ground going up, so it's right here or here. Do you remember that picture? If you're a person here, you look up from the ground. If you're a person here, you look down from the imaginary horizontal. Okay? So angle of elevation is always this guy. This one was quiz 4, so I'm just going to do it quickly. Why is it sine? Because you know op and hype. Yes, 20 is straight across. That is your op. And 40 is straight across the hypotenuse. This one's 30 degrees. I know that one. $30.0. Sure. All right, next. That one's too easy, okay? We've already done that question. Okay, let's try this one here. We haven't done this one yet. 20-meter high fire tower. I don't know what that is. Spotted at an angle of depression of 2 degrees. 2 degrees. How far is the fire from the tower to the nearest meter? So a fire tower must be somebody standing here spotting fires. I don't know. Maybe there's a fire over here. This is my rendition of a fire. So there's a fire. Okay. How do I draw an angle of depression? Can I just give you a tip? Beautiful. Angle of elevation is the same as angle of depression. So just put 2 degrees right there. Angle of depression equals angle of elevation. If you just memorize what angle of elevation is, depression comes for free. If you want to memorize it, though, you have to draw it in this horizontal line. It's right there. This is 2 degrees. So how far is the fire from the tower? Okay, first of all, where does this 20 go? The tower. 20 meters. Then it says how far is the fire from the tower? So this is confusing. It's not clear. How far is the fire from the tower? Well, most likely from the foot of the tower, but it's not especially clear. If they said how far is the fire from the top or how far from the bottom, they should say that. This question's weak. It's not your fault if you get this one wrong. I would give you the mark for both. If you found the height, I would give you the mark because it's not specific. Can we be specific? Jot it in. How far is the fire from the base of the tower? So then we know for sure that it's this one down here. So they have to be specific in the word problem. If they make a crappy word problem, that's not your fault. And on the test, we've made that test so it should be good. Now you just solve this. Well, we did it last semester, so we didn't have any issues, so it should be good. All right, so we're going to use 2 degrees and 20 and x. So what are these labels? 20 is up. No, you shouldn't get the same answer. They're just going to be off a little bit because it's 2 degrees, so it's so far that it's similar to the hypotenuse. Off a few decimals, yeah. And x is your adjacent. So we're using tan. Okay, good. What goes next to tan? Angle. So 2 degrees equals op over adj, TOA. So what goes on top? 20. What goes on the bottom? X. If I'm solving for sides, I'll put a little 1 here to help me with my cross multiplication. Cross multiply, always times the 2 numbers, divide the thing across x. 20 times 1, what's 20 times 1? Just 20. Divided by tan 2 is x. So I'm getting 572. 573. All right. Does that make sense? This is 20 meters, and then this is 573 meters. Why is it so much bigger? Well, it has to do with the degree. Think about how big 2 degrees is. Does my picture do it justice? No, 2 degrees would be like this. So that would go forever, making this overness super long. Does that make sense? What if the angle is really massive? Then it's going to go like this, and then my overness is very small. So it 100% depends on the angle. The angle determines everything. The angle is what you input into the trig function. The trig function does the work that you don't know how to do, nor do I know how to do. Before calculators, it used to be a table. They would give classes a table that mathematicians had worked out. And then you would look at your ratio in the table before these were widespread. Okay, so before technology, there was just a table. Okay, so the sine, cos, tan is kind of just a magic that we rely on. And then you input an angle. And then you make sense of the problem. Okay, next one. Sailor in a boat on the ocean. Looks toward a cliff. All right, so let's draw that. You got a sailor on the boat. There he is, chilling on the boat. He looks towards a cliff. There's your cliff. Here's your boat. If his angle of elevation is 35, okay? Up from the horizontal, 35. And the cliff is 110 meter high. How far is he from the base of the cliff? See how they were very specific? So you're looking for that overness. So what happens here is this isn't perfect in actual life, but all you do is approximate it with a right angle triangle. There's your right angle triangle. What labels do we have? Cliff is op. The overness from the base is the... What's the overness on the base? Edge or hype? Edge. Because the 90 is right there, so this is your hype. We don't care about the hype. Which one does op and edge? 10. What goes next to 10? Angle. We're solving for sides, so put it over 1. Op goes on top. 110. Edge on the bottom, x. If it's in the denominator, you'll end up dividing. So 110 times 1, still 110. Divide out 1035. So 110 dividing 1035 equals x. All right. 157 to 1 decimal place, 0.1 meters. Okay, assignment page 111, 3 to 6, odd. What does that mean? If it's like A, B, C, D, E, you just do every second question. Okay? Like Sydney said the other day, you know, it gets repetitive. But math is similar to like sports. Okay, how are you going to get better at your jump shot? By doing it, by watching the coach do it and then doing it once or twice and then never doing it again? Because that's the kind of thing that I see happen all the time. Kids watch me do it, they understand it in the moment, they do a couple in class and they forget about it. They don't ever do it again. And then what happens? You lose it. The brain is like every other muscle. You got to keep working it. Yeah. So 30 minutes to do homework. That's plenty.